Imagine receiving a message from yourself. But it's not from your past or future. It's from a you that's living their life in reverse, in a universe where time flows backward. As you read these words, they're unwriting them. As you age forward, they grow younger. When you first open your eyes each morning, they're closing theirs to sleep. But this isn't science fiction. It's a possibility rooted in some of our universe's most fundamental physics. The discovery would begin quietly, in the data streams of our most powerful telescopes. Astronomers would notice something peculiar: galaxies moving in ways that defy our understanding of gravity. Not just unusual movement, but perfect mirror images of known galactic behaviors, as if these celestial bodies were playing a cosmic film in reverse. But unlike a reversed video, these galaxies would be obeying all known laws of physics, just in the opposite temporal direction. This is where our story intersects with one of physics' most profound symmetries: CPT, charge, parity, and time. In the 1950s, physicists discovered something remarkable about our universe's laws. If you flip the charge of every particle to its opposite, turning matter into antimatter, mirror all spatial dimensions, and reverse the flow of time, the resulting universe would behave exactly like ours. This isn't just theoretical speculation, it's a mathematical requirement of our most fundamental physical theories. The implications are staggering. Somewhere out there, an entire universe could exist where time flows backward relative to ours. A universe where eggs unscramble themselves, where broken glasses leap back onto tables and reassemble, where dead stars burst into brilliant life from their cold remnants. And most mind-bending of all, a universe where conscious beings experience their lives from death to birth, accumulating memories of their future while moving toward what we would call their past. When physicists first proposed the possibility of a time-reversed universe, it wasn't just wild speculation. It emerged from the mathematics of quantum field theory, the same framework that predicted antimatter before we discovered it. In fact, the legendary physicist Richard Feynman once suggested that antimatter could be viewed as regular matter moving backwards in time. This wasn't just a clever metaphor, it was a mathematically consistent way of understanding particle behavior at the quantum level. But this raises a profound question. If the laws of physics work equally well forwards and backwards, why do we experience time in only one direction? The answer lies in something called entropy, the tendency of ordered systems to become disordered over time. It's why hot coffee cools down, why buildings crumble, and why you can't unscramble an egg. Or can you? In our mirror universe, entropy would increase in what we'd consider the backward direction. From their perspective, it's our universe that's moving backwards. Imagine watching a movie where someone drops a glass. In our universe, we see a perfectly good glass shatter into countless pieces, entropy increasing. But in the mirror universe, they'd see those scattered shards mysteriously gather themselves together, forming a perfect glass, completely natural from their perspective. This symmetry extends even deeper into the fabric of reality. Wheeler and Feynman developed a theory suggesting that every particle's behavior is influenced by both its past and future interactions. In their framework, time itself becomes less like a river flowing in one direction and more like a vast cosmic dance, with particles responding to both future and past events simultaneously. But here's where it gets truly mind-bending. Consciousness. In this mirror universe, beings would be born old and die young, with memories forming of what we'd call their future rather than their past. Every thought, every decision, every moment of awareness would flow in the opposite temporal direction to ours. Yet from their perspective, their consciousness would feel exactly as natural as ours does to us. The most tantalizing question emerges: could we ever communicate with this mirror universe? The answer lies in the quantum realm, where the conventional rules of time and causality become surprisingly flexible. The key might lie in something physicists call quantum entanglement, what Einstein famously termed spooky action at a distance. Imagine two entangled particles, one in our universe and one in the mirror universe. In our time direction, we measure one particle, instantly affecting its partner. But here's the mind-bending part. This effect appears to be instantaneous, operating outside of time's normal flow. If entanglement can ignore time's arrow, it might serve as a bridge between our two temporal directions. But what would such communication look like? It certainly wouldn't be like sending a text message or making a phone call. Any message would need to be encoded in quantum states that could maintain their coherence across the temporal barrier. Think of it like trying to have a conversation with someone when your words travel backwards in time to reach them, and their response travels backwards in their time, forwards in ours, to reach you. The implications for causality are staggering. If you received a message from the mirror universe, would it be from their future, our past, or their past, our future? The very concepts of before and after become meaningless at this interface between temporal directions. It's a paradox that challenges our most basic assumptions about cause and effect. Some theoretical physicists suggest that such communication might already be happening at the quantum level. Those unexplained quantum correlations we observe, they might be subtle influences from our mirror counterparts, their actions rippling backwards through time from our perspective, creating what we perceive as quantum uncertainty. Even more intriguing is the possibility that these interactions might be happening at the scale of black holes. The information paradox, the question of what happens to information that falls into a black hole, might be resolved if black holes serve as natural interfaces between forward and backward flowing time. The discovery of a mirror universe moving backwards in time wouldn't just be a scientific curiosity, it would fundamentally reshape our understanding of existence itself. Consider our most basic assumptions about the universe's history. The Big Bang as a beginning, the eventual heat death as an end. But in a cosmos with bidirectional time, these events take on new meaning. What we call the Big Bang might actually be a mirror point, a cosmic interface where time flowing in both directions meets. From our perspective, we see an explosion of matter and energy marking the universe's birth. From the mirror universe's view, they see what we would call the Big Crunch, a final cosmic collapse. Both perspectives are equally valid, equally real, and perhaps even necessary for the universe's existence. This duality forces us to confront deep questions about consciousness and free will. In our universe, we feel we make decisions that affect the future. In the mirror universe, conscious beings would feel they make decisions affecting what we call their past. Yet both experiences would feel equally real, equally deterministic, yet seemingly free-willed. It suggests that consciousness itself might be something that transcends our conventional understanding of time's flow. The implications extend to the very nature of information and knowledge. In our universe, we can only remember the past, never the future. But in the mirror universe, beings would only remember what we call their future, never their past. This perfect symmetry suggests that the flow of time might be more about the flow of information than any inherent cosmic direction. Perhaps most profound is what this tells us about reality's structure. If two opposing time directions can coexist, each making perfect sense from its own perspective, then time itself might not be the fundamental thing we thought it was. Instead, it might be more like a dimension we move through, with different possible directions of travel all equally valid. This brings us to the ultimate question. What if our universe isn't just paired with one mirror universe but exists in a vast cosmic network of universes flowing in different temporal directions, each making its own kind of sense, each contributing to a greater reality that transcends our limited conception of time's arrow? These theoretical possibilities aren't just philosophical curiosities, they're driving real scientific research. Particle physicists at facilities like CERN are constantly probing the symmetries of time, searching for subtle violations in particle behavior that might hint at connections to other temporal domains. Every new discovery about antimatter brings us closer to understanding if it truly could be matter moving backwards in time. The search has practical implications too. If we could understand and harness temporal symmetry, it might revolutionize our approach to quantum computing. A quantum computer operating across temporal directions could potentially solve problems that would take conventional computers billions of years. It's not about sending information back in time to get answers faster. It's about utilizing the fundamental symmetries of physics to process information in ways we can barely imagine. Consider the implications for energy and entropy. Our universe's apparently inevitable march toward heat death might be balanced by processes running in reverse in the mirror universe. This cosmic balance might be essential for the universe's stability, suggesting new approaches to understanding and potentially harnessing energy at the most fundamental level. But perhaps the most immediate impact would be on our understanding of consciousness and free will. If conscious beings can exist experiencing time in the opposite direction, yet feel their experience is just as natural as ours, it suggests consciousness itself might be more fundamental than time. This could revolutionize our approach to artificial intelligence, suggesting that true consciousness might require systems that can process information bidirectionally in time. The search for the mirror universe continues in unexpected places. Astronomers study galaxy clusters for signs of anomalous behavior. Quantum physicists probe the foundations of entanglement. Cosmologists analyze the cosmic microwave background for patterns that might indicate interactions with time-reversed regions of space. And perhaps right now, in that mirror universe, another you is hearing these same words, thinking these same thoughts, but experiencing them in reverse. Their questions flow backward toward answers we're still seeking, their discoveries unfolding in a direction we can barely comprehend. Remember that message we imagined at the beginning? The one from your temporal mirror self? Perhaps it's already here, encoded in the quantum fabric of reality. Every time we observe quantum phenomena behaving in seemingly random ways, we might be witnessing the echo of decisions made by our counterparts in reverse time. Their future rippling backward to meet our present, their consciousness interacting with ours through the subtle dance of quantum probability. The most profound implication isn't just that time can flow backwards, it's that our entire conception of time's flow might be too limited. Just as humans once thought the Earth was flat because we could only perceive its local geography, we might think time only flows forward because we're limited by our local experience of temporal direction. If we ever do definitively discover this mirror universe, it won't just be a scientific breakthrough, it will be a moment of cosmic self-awareness. We'll understand that we're not just passive observers moving through time but active participants in a vast cosmic symmetry. Every action we take ripples both forward and backward through time's fabric, creating patterns that echo across both temporal directions. And perhaps that's the true message from our mirror selves. That reality is far more interconnected than we imagined. That every moment exists in perfect balance with its temporal opposite. That consciousness itself might be nature's way of experiencing this profound symmetry from both directions. The next time you look in a mirror, remember, you might not just be seeing a spatial reflection but peering across a temporal one as well. In that other universe, another you looks back, wondering the same things, asking the same questions, but experiencing them in an eternal cosmic dance of forward and backward flowing time.